Welcome. Today, let's explore the world of transportation and logistics, focusing on smart solutions for modern supply chain management. We'll be looking at how technology and data are transforming the way goods are moved and managed, making it more efficient and cost-effective. We will discuss route optimization, fleet management, and supply chain analytics. Now let's start with route optimization. Route optimization means finding the most efficient paths. It is the process of determining the most cost-effective route for multiple stops, considering factors like distance, time, traffic, and vehicle constraints. By optimizing routes, businesses can achieve key benefits like reduced travel time, lower fuel consumption, significant cost savings, and a reduced environmental impact. Let's dive into the core mathematical approaches that power route optimization. Some of the popular algorithms used include Dijkstra's algorithm, which finds the shortest path between two nodes, genetic algorithms, which use an evolutionary optimization approach, and ant colony optimization, which applies a swarm intelligence method. Here's a simple Python implementation example that uses the Network X library to find the shortest paths within a graph, calculate the total distance, and optimize routes. Next, let's explore fleet management, which is a comprehensive approach to managing a company's vehicle fleet. This includes everything from the acquisition and maintenance of vehicles to tracking their location, managing fuel consumption, overseeing drivers, and even the eventual disposal of vehicles. Core components of fleet management are vehicle tracking using Global Positioning System, or GPS, monitoring, maintenance involving scheduled services, fuel management through consumption tracking, and driver management focusing on performance monitoring. Let's see what digital solutions are used for modern fleets. Key technologies in fleet management include Global Positioning System, or GPS, tracking for real-time vehicle location monitoring, telematics for vehicle diagnostics and performance data, and Internet of Things, or IoT, sensors for monitoring temperature, fuel, and cargo. Here's a simple fleet tracking system implemented in code, demonstrating how to track vehicle locations, timestamps, and status. Now let's explore supply chain analytics. Supply chain analytics involves applying mathematical models, statistical analysis, and optimization techniques to improve supply chain decision-making and operational efficiency. Key analytics areas include demand forecasting, which predicts future demand, inventory optimization, which manages stock levels, transportation planning, which optimizes delivery routes, and performance monitoring, which tracks overall efficiency. Let's understand the different data categories used in supply chain analytics. The three main data categories are transactional data, which includes orders, shipments, invoices, and payments, operational data, which covers inventory levels, production rates, and quality metrics, and external data, which includes market trends, weather, and economic indicators. Here's a simple example of how you can analyze supply chain data using Python and the Pandas library, processing transactional data to calculate key metrics like average delivery time and order volume. Let's explore the various methods and technologies for supply chain analysis. Key techniques include predictive analytics for forecasting future demand and trends, prescriptive analytics for recommending optimal decisions, and machine learning for pattern recognition and automation. Popular tools used in supply chain analytics are Python, a programming language, Tableau, a visualization platform, Apache Spark for big data processing, and SAP Analytics, an enterprise solution. Now let's see how it all comes together as we consider integration and applications. An integration flow involves collecting transportation data, applying route optimization, monitoring fleet performance, and analyzing supply chain metrics. Real-world applications include e-commerce delivery, where last-mile optimization is critical for online orders, food distribution, which requires cold chain management, manufacturing, which involves raw material procurement and delivery, and emergency services, which rely on efficient medical supply distribution networks. Finally, let's look ahead to the future trends in transportation and logistics. Emerging trends include autonomous vehicles like self-driving trucks and delivery robots, artificial intelligence and machine learning for advanced predictive analytics, and blockchain integration for enhanced supply chain transparency. In conclusion, transportation and logistics optimization through data-driven approaches creates significant competitive advantages. Route optimization reduces costs, fleet management improves efficiency, analytics enable better decisions, and integration maximizes benefits. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.